Okay, so today we're going to talk about rate of change and slope. Rate of change and slope. We talk about both of these together because they actually are exactly the same thing. Rate of change we typically talk about when we are working on word problems. The rate of change of, speed of a vehicle will have a rate of change, will go from slower to faster, or you're building money up at a different rate. You've got a rate of change. How much is it building up over time? When we talk about slope, very often we are talking more in terms of an equation and solving an equation. But both are exactly the same, and we'll be seeing that as we go along. So we're going to start with our rate of change. And when we talk about our rate of change, what we are talking about are change, and in the future we'll be using the symbol for change here, the change in our dependent variable, and I might have to shorten that a little bit so that it all fits, and that's going to be over the change, okay, and there we're using that new little symbol, in the independent variable. Now we should know at this point that our dependent variable is typically our y value. That's going to be on our vertical axis, and our independent variable, that's our x value, that's on the horizontal axis. So the change in the dependent variable over the change in the independent variable. So let's say we are looking at a chart of values, and so let's say we've got, let's see, it's 5 and 2. We've got a chart that is number of days and rental charge. Okay, and for number of days we've got 1, 2, 3, 4, and 5. Bring that line down a little bit longer, and we've got $60, and we've got 75, and 90, 105, and finally our 120. Okay, so when we look at a set of values, I always look at it and say, okay, so which depends on the other? Well, your rental charge is basically based on the number of days that you have it. So rental charge is going to be our y, our dependent value. It depends on how many days you are actually going to be renting. So if we are looking at, say, the rate of change using days 5 and days 2, we're looking at that rate of change. So we are looking at the difference between 75 and 120 and 2 and 5. Now, it honestly doesn't matter which goes first, and I will show you why that is. So let's say we are starting at our 75 minus 120 and 2 minus 5. Okay, this is going to equal 45 over 2 minus 5, and that's negative 45, sorry, and a negative 3, which is equal to a positive 15 over 1. Okay, so our rate of change is $15 per day, for 1 day. Now, if I were to have done that the other way, and we had taken the 120 minus 75 over 5 minus 2, 120 minus 75 is still going to be our 45, but it's positive, and 5 minus 2 is positive 3, which is again equal to 15 over 1. Here we had a negative divided by a negative equaling a positive, and here we have positive divided by a positive. So it doesn't matter which way you go. So this is the rate of change. So the rate of change here is that it costs $15 per day for the rental, for the change between the two. Okay, now obviously we're starting here with a base and then adding on to that. So but what we're looking at now is how much it changes over time. Okay, so that is using a chart. Now, if we are doing rate of change using a graph, let's say we have a graph, and rate of change, typically we're going to be only in quadrant 1 because our data is all real data, and typically it's positive data. So down here we're going to have on this graph, this is time down here, and 1, 2, 3, 4, 5, 6, and we've got miles on our y-axis. So, and we're going to be going up by 50s, I believe. So 50, 100, 150, 200, 250, and our line is pretty much going, yeah, it's going pretty straight up there. So just need to get my ruler properly. Okay. So they're asking us to find the rate of change based on the graph. Well, we can really come up at any point coming across here using just this simple point here. We can say that this is 50 miles per 1 hour, or 50 miles per hour. If you came out here to, well, 4, I kind of went off my line here, so 3, here we would have the 150 over 3, which is equal again to 50 over 1. So if I had kept my line going properly, we would see that you have a constant rate of change, which is 50 miles per 1 hour, or 50 miles per hour. So that's how we look at it when we are doing the rate of change. So now let's talk about slope. Okay, with slope, we are working with equations rather than actual data. So, but we basically use it the same way. So let's go ahead and build a coordinate plane quickly and look at a line. And let's see, let's look at, let me build this line. This is a lovely line here. Okay, let's see, a couple of options here with points. Okay, so with our rate of change, what we were looking at was the change in our y, which was our dependent variable, okay, over the change in our x, which was the independent variable. We're going to continue with that idea of the change in our y over the change in our x. So we're going to look at y1 minus y2 over x1 minus x2. Okay, so in this case, we're going to pick a couple of points. I pick this one and, let me see, I really came off of it a little bit, but this one is also very clearly on there. So I have these 2 points. This point is 1, 0, and this point is -1, -1. So I have my y's on top, so this is 0 minus -1, and over my x's 1 minus my -1. Okay, so 0 plus 1 is 1, and 1 plus 1 is 2. So my slope is equal to 1/2, or 1 over 2. So another way to look at this is to say that my change in y over my change in x could actually be looking at, if I'm changing y, okay, I'm looking at my rise, and if I'm changing x, I'm looking at my run. So we can also say this is rise over run. So I can look at this right here and say my rise here is just 1. My rise is 1. And my run is 2. So my slope is 1 over 2. We had already figured that out, but it's a different way of looking at it. Let's look at another graph. And let's see what kind of a line we can do with this one. Okay, and in this one I'm going to build this line here. Okay, I'm going to use this point, and I'm going to come all the way down here and use this point. So this time, let's just use our rise over run, okay? And I'm going to build my triangle, okay? And I'm going to say I've got 1, 2, 3, 4, 5, 6, 7, 8. My rise is 8. My run, 1, 2, 3, 4. My run is 4. Now, what I want you to notice with this line is the fact that I am higher to the left, lower to the right. Okay, looking at this left to right, which is how we read everything, left to right, I'm higher going lower. This is a negative slope line. Okay, a negative slope, as opposed to this one here, which is low on the left and high on the right. It's increasing. So this is a positive slope line. So when we look at a line like this and we say, well, that's 8 over 4, which is actually equal to a slope of 2, but it's going down. It's going in a negative direction. So this line has a negative 2 slope. Okay? So that is one way to look at it. We'll talk about other ways to look at these negative and positive slope lines. But let's look first at when we have points. So let's say we are just going to look at our points, and we have point C, which is 2, you can't even see what I'm doing, there we go, which is 2, 5, and we have D, which is 4, 7, and because we know that we're talking about the change in y over the change